Hello everyone, today we are going to discuss regarding the voltage regulations of an alternator using synchronous impedance method. In this method, we are first find out the synchronous impedance of an alternator, then we are go for the voltage regulation. There are also other methods is applicable, for example American Standard Method, Portier-Dreymus method and your MMF method, but this time we are only focusing on this method. This method also known as a pessimistic method, or it is called also EMF method. Now first question has arisen, what do you mean by voltage regulation? The voltage regulation is generally denoted by the Vrags, or we can say the regulation. First of all, what do you mean by the regulations? The regulations of any parameter, say for example a motor speed, say is your n, then if the environment is changed, for example if it is completely a non loaded to a completely loaded condition, then the speed become my nr. Then what is the regulations are change, then the parameter change in your percentage format, that is called a regulations of any parameter. So here the voltage is our concern. So voltage regulation is nothing but your V at no load scenario, then V at your full load scenario divided by the voltage at your full load scenario into your 100 in percentage. We are going to dip inside these equations whenever we move gradually inside this theory part. Now go for the familiarizations of the circuit in a per phase basis. This is a per phase circuit diagram of an alternator, three-phase alternator is that. Now this is your EF, or it can be written like a EF into your delta. The delta is the angle in between your voltage phasor of the terminal. It is generally denoted as V0 or Vt. It is equal to your V angle is 0. In generally in your power system, the terminal voltage taken as a reference phase, so that's why the 0 is marked at here. Now this diagram itself neither represent an alternator nor a motor. If we give a directions of the armature current like this, then it will become an alternator. Now think about the parameter. This is your armature resistance, this is the armature leakage reactance, and this is called your armature reaction reactance. It is a fictitious parameter. If we go for the mathematical derivations, then you find that it is a fictitious parameter which is only present if and only if your armature current will flow in a circuit, otherwise it is a completely a fictitious one. Now and this path don't have any resistance, is called your zero impedance written path. Now the voltage equations for this will be your EF equal to Vt plus your Ia plus your Ra plus of your Zs. Zs and these two Xs is equal to your Zs. This is called your synchronous impedance. Now this Xs having a two part armature leakage reactance plus of armature reaction reactance. Now gradually we move for the voltage regulation part. In your lot of books is define the voltage regulation in lot of way, but the standard thing is that voltage regulation is a change of the voltage of an alternator if it throw off all its load completely. That means whenever your it is a not loaded condition, now the alternator run in a full load conditions or somehow some loads are there, then it's completely throw off, then how much voltage rise or voltage change is there, that voltage in percentage format will give you the voltage regulation. And always remember that these voltage are the magnitude of the voltages, because it is nothing but a complex parameter. If you represent in a polar coordinates, then you will find one is magnitude part, another is the angle part. So always remember to take only the magnitude part at here to put these values. All these values are the magnitude 1, so it is a common mistake done by the students. So let's proceed further. How to find out the voltage regulations? That the in outside the terminal of the machine we can observe the VT, or the terminal voltage. This is the terminal voltage, but how to find out if it is not loaded? Then we have to go for these equations. The EF is nothing but your VT plus of your IA into your RA plus of your J of XS. Now, in somehow, if we able to measure the machine's armature resistance and your synchronous reactance, then we can find out for a particular load what is your generated EMF, and this generated EMF is equal to Vt when my current is 0, when my armature current is 0. That means it is a open circuit conditions. That means this Vt is nothing but your VOC at particular instant. Now our problem is that to find out this axis. Now what is that? The synchronous impedance definition is that the voltage, open circuit voltage divided by short circuit current for a particular field is called the synchronous impedance of the circuit. Now to get this synchronous impedance, we have to perform two tests. Those tests are your OCC and your SCC test. The OCC, the open circuit test, is performed to run the alternator at its standard frequency by a given driving force, and we are measuring the open circuit voltage by gradually changing the field current, and the circuit or the graph looks like this. The graph is starting linearly, then it is magnetically saturated. So this line is your field current axis, and this line is your VOC voltage. Then there is another performance have to be done, that is called the short circuit test. In that case, the armature terminal are shorted and one ammeter is placed in between any two terminals, as it is machined in your balance condition, so we need not to think about anything, that the line current and the phase current are the same. The short circuit current and this characteristics is your straight line. Why it is straight line? Go for the textbook or in a class so you can understand. Now if you merge these two graphs, then what you will find out? If you merge two graphs, then this looks like that. This now this is your OCC, and say this one is your short circuit characteristics. Now the ZS is nothing but your VOC divided by ISC for a particular field current. So it is your field current axis, and your this one is your VOC, and this one is your short circuit current. Now if we find out this parameter, then in each point if we divide it, then you find this parameter is there, and this is your ZS. Now the question is appear throughout this test, you will find a lot of ZS. Which ZS should I take for the further calculation? Remember always, the machine is designed to operate almost a magnetic saturated area. That means the machine is operated in this zone. So we take the possible minimum value from the experiment of the ZS. Now to already the ZS is known. Now using a multimeter we can find out the per phase armature resistance. Then if RA is unknown by measuring it by a multimeter, then what is the XS is nothing but a under root of your z square minus of your r square. So we getting the value of this axis. Now under certain load conditions, say your Ia is equal to say 5 ampere and the power factor of that load is your say purely resistive, so your 0 angle, so your 5 angle 0 ampere current. So what is the your your EMF, generated EMF? So the terminal voltage, say the terminal voltage in per phase is your 220 volt angle 0 plus of your 5 angle 0, then you put the value of your RA plus of your XS, that will give you the your EMF, and this EMF in a polar coordinates format having a two parts, that's your magnitude part and the angle part. To find out the voltage regulations, you have to put only the magnitude part of this minus of your Vt divided by your Vt into your 100 will provide you the voltage regulations of the alternator at this particular loading level. So this much is a theoretical background to perform the experiment. We are go for the next video for the experimental setup and other things of the video. Thank you.